Okay, welcome to the last lesson of the year, the last new thing that we're learning. And it's not even that new. We're just combining all of the surface area stuff and volume that we've already done. And we start off the lesson with our last postulate in geometry. Probably your last postulate ever, because we don't really use that in algebra. We like theorems more in algebra than postulates. So, postulate, volume addition. The volume of a solid is the sum of the volumes of all its non-overlapping parts. So let's jump right into this thingy. This is a composite shape. It is going to be something that is made up of multiple shapes. So what we could do is like split this down the middle here, right? And say, hey, this part over here is its own shape. And maybe this part right here is its own shape, and then we have the part in the middle is its own shape. And what this says is that we can find the volume by just breaking it up into multiple pieces. So now that we kind of hopefully understand what a composite piece is, we're going to try to figure out what the volume of this is. And the easiest way for this one is I'm actually going to split it this way. This kind of top piece, I'm going to chop it off. Okay, and I'm going to do the same thing with this top piece here. Okay, I'm going to chop it up. And the reason I'm doing that is because it'll just be easier to find everything. For example, if this thing is 2 by 2 units and I have this little unit cube here, I know that it's going to take up 4 little cubes if I were to divide it up. This thingy right here, I can split up into 2 cubes. So there's this one that's right here, and then there's this one that's back here. Hopefully you can kind of see that that is 2 of these cubes. And then along the bottom, there's 7 by 2. So there's going to be 7 in the first one, and then there's a second row back here. There'll be another 7. So that part's going to be 14 in this bottom. And what this postulate says is if I add all these up, that's going to give me the volume of this entire thing. Okay, and I didn't need like a crazy formula. I could just count because this one was easy. All right, let's see if you can figure it out with this one. So there's no guidelines in the middle, and you should pause the video and you should see if you can figure it out yourself. You totally paused the video, right? Yeah, you did. I believe you. What I would do here is divide this thing up into different pieces here. So I have 3 units along the bottom, so I split it up into 3 sections. There's this little 1 unit up top, and then based off of this 2 units right here, I split this guy up into 2. So I can now actually just count 1, 2, 3, 4, 5, 6, 7. This thing is going to be 7 units cubed for its volume. That's crazy, right? So much fun. I know. You're having a blast. All right. This is going to be a little bit trickier, but I swear it's not crazy. We want to try to find the surface area of this shape. And if you can kind of picture what's happening here, we have a cylinder. So think of like a can of soda. And then we have a semicircle that's cutting into it. So it's going inside of it. So it's almost like if you took the soda can and turned it upside down and it has that kind of divot on the inside. That's kind of the shape that we're thinking of here. We have a soda can with a semicircle, a sphere, a hemisphere. Whew, words are tough. A hemisphere down there on the bottom that's kind of cutting it out. And so if we want to find the surface area, we have to think of everything that's going to be exposed to the surface, right? And so if we're thinking about that, we're going to have the circular base along the bottom of the cylinder, okay? So I'm going to have the base of the cylinder as part of what my surface area is, plus the lateral area of the cylinder. So that's the sides of the cylinder. Now, I don't have 2 bases because this part up here, which would be part of the cylinder, well, it's not actually there because there's actually the hemisphere that's happening on the inside, right? So this part right here replaces that base with a hemisphere, which is half of a sphere. So what I'll add here is half of the surface area of a sphere. And so now that we have this, we can just use our formula. So we can say, hey, the base of a cylinder is always a circle, so we know that that's pi r squared. The lateral area of a cylinder, if we just look at our formula sheet, is 2 pi r h, okay? And then if we're doing half of a sphere, so a sphere is 4 pi r squared, so we're just doing half of that. Now all I have to do is just plug everything in. So they tell us right here, our radius is going to be 2, and our height is going to also be 2. So I can say pi 2 squared plus 2 pi times 2 times 2 plus 1/2 times 4 is going to be 2. So I'm just going to combine that. And then I'll have pi, and then my radius is 2 squared. So I just did a little bit of math to save us some time and effort there. So we're going to have 4 pi plus 8 pi plus 2 squared is 4 times 2 is going to be another 8 pi. I'm going to add all that up. I'm going to get that the surface area of the shape is 20 pi inches squared. Area, so inches squared. So to kind of summarize here, we really focused on what would be exposed to the air, or if like we took this and dipped it into a bucket of paint, what would get paint on it. And so we have the base of the cylinder, the sides of the cylinder, and then the hemisphere that's in the inside there. Okay? If we flip to your turn, this time it doesn't give us a picture, so we get to draw it ourselves. I'll help you draw the picture, and then you should pause the video and go from there. So let's see here. We have a solid consists of a hemisphere, so that's half of a sphere, with a radius of 1 meter on top of a cone with the same radius and a height of 5 meters. Okay, so this is an ice cream cone with ice cream on top. We have our cone here, and then we have our sphere on top. Okay, things we know about it is that it has a radius of 1 and it has a height of 5. Things that we don't know is we don't know the lateral area of the cone, but we know everything else that we need to do. All right, so you should pause the video at this point so that you can try this on your own and make sure that you can at least write the first sentence down, which is what I did with words up here, where I kind of described what is the surface area that I need to find. All right, so pause the video and try it yourself. Did you pause? Oh my God, I'm so proud of you. Thanks for pausing. You're great. All right, if I'm going to do this stuff, surface area, we're going to have the lateral area of the cone. That's just the sides of the cone and not the top of the cone or the base of the cone, because that's going to be covered by this hemisphere or the scoop of ice cream, right? We wouldn't actually see the opening of the cone because there's this sphere on top of it. And then we're going to add the half of the sphere, and only half of it because the other half is underneath the cone, right? It's inside the cone. We took the full scoop of ice cream and we can only see half of that sphere. So now we can just look at our formula sheet. We'll get pi r L for the slant height for the cone, and then we're going to do our 1/2 for pi r squared for the surface area of the sphere. Now, I need to do a little bit of math here. I don't know what L is, so we luckily know that in a cone, we have that the height squared plus the radius squared is always equal to the slant height squared. So this is going to be 26 equals L squared, so L is going to equal the square root of 26. All right, so when we go to plug this stuff in, I'm going to have pi, my radius is 1. We just figured out that the slant height is the square root of 26. And then over here, I'm going to do that same little shortcut. 1/2 times 4 is 2, and then pi times 1 squared for our radius. And we have 1 times the square root of 26. When we have square roots, we typically write the things in front of them. So I wrote this as pi square root of 26. You could just as easily write it as the square root of 26 pi, but if you're going to do it this way, then you want to put a little drop down there to say, hey, the 26 ends where the square root is, the pi is not underneath it. And then over here we have 1 squared is 1, and so we would have just 2 pi. And this is a perfectly acceptable answer to leave it written just like this. If you want to put it in your calculator, you could do the square root of 26 times pi plus 2 pi, and you would get 22.3 meters squared. I guess you could also, if you really wanted to be a little crazy here, write it as 2 plus the square root of 26 times pi like that. I don't really see any purpose for us in this class to do it that way. I would leave it as one of these two answers, either the decimal or the exact one with them separated. And hopefully you didn't find that too crazy, right? The key thing here is for surface area, which is the hard ones of these. Volume's much easier. Surface area. You just have to really think about what's exposed to the outside. And in this case here, everything that's in here, this little circle bit, which would be part of the cone's base, and also the underneath part of the sphere would not be exposed to the surface, and so we don't include it as part of our surface area. All right, next we have volume. So volume is, I think, much easier. In order to calculate the volume of a composite shape, you first identify what the two shapes are. So if I'm looking at this, I see that we have some sort of prism and a pyramid. So when I'm doing this, I'm going to say, hey, the volume is going to equal a prism plus a pyramid. never know if I'm spelling pyramid right, but I think I am. And if we look at our formulas for prisms, it's base times height, where B is equal to the area of the base, and H is equal to the height of the prism. And then for our pyramid, it is going to be 1/3 BH, where again, B is the area of the base of the pyramid, and H is the height of the pyramid. So I'm going to try to color code this a little bit. For the base of our prism, it looks like it's going to be this shape down here. So that's going to be 6 times 6, and then the height of the prism itself is also 6. So I'm doing 6 times 6 times 6, which is going to be 216. Then I'm going to do the 1/3 the area of the base of the pyramid. Well, the base of the pyramid is actually the same as the base of the prism, so it's going to be 6 times 6. And then the height was given to us of the pyramid is also 6. So we're going to be doing plus 1/3 of 216, so 1/3 times 6 times 6 times 6, and that's going to be 72. And if we just add all these up, we're going to get 288 meters cubed, because we're talking about volume. So see, that was much easier, right? We just have to find out the different pieces, and it's only going to be as difficult as it is to find those pieces. So in a prism, we have to find the area of the base. So if it's a nice base, like a rectangle or a triangle, then we can find it pretty easily. If it's a pentagon or hexagon or other polygon, then it's a little bit harder. Same thing with the pyramid. They're only as hard as it is to find their base. All right, now we have your turn. I'm going to help you draw this one, and then you should pause the video and go from there. So we have a right cylinder, which just means that we have a cylinder that's not like, like a slinky and leaning to the side. It's just straight up and down. It has a radius of 3 and a height of 10, and then it has a cone on top of it, same base and a height of 5. So we're going to draw our cylinder. So we kind of draw like a slanty little circle there, a little oval shape, one on top, and then we just connect it, and there we go. We have our cylinder, we have our cone on top, and then we can label things on the inside here. So we have that the height of the cone was 5, the radius is going to be 3, and the height is going to be 10. So you should pause the video now and see if you can figure out how to find the volume of this shape. Did you pause the video? You did. I know you did this time, right? You wouldn't not pause it again. You did? No, you didn't. No, you didn't. All right. If we're doing this stuff, we're doing cylinder plus cone, right? Volume of a cylinder is pi r squared h. We just look straight at our formula sheet. And cone is 1/3 pi r squared h. And we were given all of this stuff. So our radius of our cylinder was 3, so we're going to do pi 3 squared. The height was 10. And for our cone, we're going to do r is 3, and the height of the cone was only 5. All right? So if I do 3 squared times 10 in the calculator, I'm going to get 90 pi. Remember, we just ignore the pi when we're typing it in the calculator. Same idea here. I'm going to do 1/3 times 3 squared times 5 in the calculator, and that will give me 15 pi. And when I add those up, I'll get 105 pi. And our units were centimeters, and this is volume, so centimeters cubed. So we have 105 pi centimeters cubed. And there you have it. That is surface area and volume of composite shapes, and our last new learning of the year. Woo! How exciting is that? All right, you have some practice here. So we got some of the basic ones where you just kind of divide it up and figure out what the volume of each one is. Then we have surface areas of these two things here. So remember, you don't want to include things that are on the inside, like, for example, that base that did not highlight at all. Woo. That base that's right there, nope, doesn't work, doesn't want to highlight. That base is not exposed to the outside. That base up here, not exposed to the outside, so we wouldn't include it, just like our examples. And then now we want to find the volume of these two shapes. For this one in your homework, this is removing a hemisphere, okay? So if we're removing, you should think about how that would affect our equations, all right? And then there's lots of optional extra practice in case you want it. It can get as crazy as you can imagine. Oh, this one's fun. It has like a block that's been removed from the middle of it, and this one has a cone that's been removed. So super fun if you want to do those optional ones. And yeah, hopefully this made sense. And I will see you next class. Bye, friends.